We're given that the sine of theta is 5/13 and this angle falls in the second quadrant. And we want to find the sine of 2 theta using the double angle formulas. Remember, you can pause at any time to write down this problem. So we're going to choose this formula on the top of this box. The sine of 2u equals the sine of u cosine of u. Well, we know this piece already. The sine of theta is 5/13. And we need to find out what is the cosine of theta. So we're going to use the Pythagorean identity. Sine squared of theta plus the cosine squared of theta equals 1. And we're going to substitute in 5/13 in for the sine. So remember that's a squared. And then we're going to solve this for the cosine of theta. So we're going to do some undoing. So 5/13 times 5/13 is 25 over 169. And the rest of the equation stays as it is. Now we're going to subtract 25 1/69 from both sides. So we're 1 minus 25 over 169. And now we want to combine the terms on the right side of this equation. So I'm going to change that 1 to 169 over 169. Now I have like denominators. So now I can go ahead and subtract the numerators. 169 minus 25. And then all over 169. So we have 144 over 169 cosine squared of theta. Well, we want it to be the cosine of theta, so we have to undo that squared. So we're going to square root both sides. So we have the cosine of theta left on the left, plus or minus the square root of 144 over 169. Now we can split up that radical into two radicals. So we have square root of 144, square root of 169, which is plus or minus 12 over 13. Well, let's go back now to our domain. Our domain was given as pi over 2 to pi. So that falls in the second quadrant. Here's pi over 2. Here's pi. Our theta falls in here, which is the second quadrant. Remember that the sign has to be positive, and the cosine has to be negative in the second quadrant. So we're going to choose then that the cosine of theta be negative 12/13. All right, now we can go ahead and evaluate for the sine of 2 theta. The sine of 2 theta is what we want to find. So now we can substitute it in over here in the box. 2 sine of u cosine of u. So the formula for the double angle for the sine of 2 theta equals 2 sine of u, which we'll just change it to theta, times the cosine of theta. 2, so change that to 2 over 1, since we're working with fractions. Sine of theta was, up here given, 5/13. So substitute 5/13 in. And then cosine of theta we just found, right here, negative 12/13. And let's multiply across. So you multiply those numerators first, so 2 times 5 times negative 12 is negative 120. And then 1 times 3 is 169. So the sine of 2 theta is negative 120 over 169.